Hello everyone. So in this video, we are going to cover a highly requested topic for Vitess, which is query certification. So this video is relevant if you are already familiar with how Vitess works, and now you want to answer questions about how to make it work for you. In particular, this video will help you deploy your schema in a Vitess test environment, and then try out your queries to see what works and what doesn't work. It will also allow you to experiment with different sharding schemes and the effects they have on your queries. But before watching this video, it will be helpful to brush up on vschema and Indexes. You can find this document under vitess.io. So if you click on guides and on the link, you can select the vschema guide and just go through this and refamiliarize yourself, because it will be easier to follow along. I presented this demo at Percona, and my friend Simon suggested that this would be a good example for this tutorial, which I thought was a good idea. So I decided to show you how to build something like this from the ground up. You can then apply the same process to your schema. So in this scenario, we are modeling an app that allows users to upload their music. Then presumably others will listen to it, comment, etc. So this is a skeletal representation of those tables. So in the user table will have a user ID as primary key. It will contain additional data about the user, which is not listed here. I'm only showing important columns of the table. As the users upload their music, that information will go into the music table. And the user ID will be the foreign key into the user. Music will also be identifiable by music ID. And then we have the music extra table that stores additional metadata about the music table. Maybe something like a row each time a viewer listens to it, etc. So this is a fairly straightforward schema if everything was in a single database. So let's say that we have to shard this database. We actually have multiple options here, and the correct choice will be dictated by actually the use cases. So the user table is a relatively straightforward decision. We shard it by user ID. And you do this by specifying a primary index on it. So the one flexibility that Vitess gives you is that you can choose your sharding scheme for each index. In this case, we've chosen a hash-based sharding scheme. And if you looked at the vschema document that I showed earlier, you'll see that there are multiple other options that you can choose from. So if the user ID had an auto-inc in the original MySQL column, that's not going to work in the sharded scenario anymore. So to address this, Vitess has the sequence feature, which generates numbers for you, just like auto-inc, but for sharded tables. So this basically is essentially a single row table that issues numbers as requested. And because it is a single row table, it needs to be in an unsharded database. So it can't be with the other guys. So we'll put this in a new database called Lookup. And we'll eventually put more things in there. So basically, once this is done, the user table is successfully configured for sharding. So now coming to the music table. This table could be sharded by user ID or music ID. The choice really depends on which queries are more frequent. So in our case, let's assume that the app frequently requests all music of a user. So this means that it's better to make the music rows live with the user's rows. So you do this by basically saying that the music table is also sharded by user ID, and that it uses the same index as of the user's user ID. But then you may still want the ability to effectively fetch a music row by the music ID. So if this was a requirement, we could define a lookup index on music ID. So this index will require a table which will map every music ID to the same key space ID that the user ID generated. So when you later query by music ID, Vitess will use this lookup table to identify the key space ID and then route the query accordingly. So the lookup table is like any other table. We could actually shard it if we wanted, but for the sake of simplicity, we'll assume that it's unsharded, and we'll host it on the lookup database. And obviously, music ID will need a sequence, which will also be in lookup. So finally, the music extra table. So since this has only music ID as an interesting key, we have to shard by that. So one choice would be to hash it like user ID. But that may not be beneficial. And what if we want the music extra rows to live with their parent row? If that is the requirement, we can do this by specifying that the music ID column's primary Windex uses the same Windex used by music ID. So basically, you say that they are sharing the same Windex, which actually also means that they'll share the same lookup table. So what was actually a secondary Windex for music actually becomes a primary Windex for the other table, the music extra table. So this is the full schema. So what we have done is we have added 3 tables, user sec, music sec, and music lookup. And we have added some additional metadata that describes how things are sharded in the vSchema. So the next step is to actually express it, and that's what we are going to do next. So I've now started off a brand new screen session, and we'll go through the exercise of creating this test. So our starting point is actually the original base schema, which is right here. I've pre-created this directory, my app, where I've put all these files. If you look at the base schema here, you will see that it has the original 3 tables that we talked about, and you'll also see that these columns are still auto-increment. So this is the original schema that the app is using. And I've also created 2 other files. One is the test file, which contains a list of queries we intend to run against Vitess once we have deployed the sharded schema. Supposedly these queries were collected from the app. And I also have a simple Python script that just reads this file and executes these queries against Vitess. So this is basically our starting point. At this point, nothing else is created. So what we are going to do now is actually reverse engineer our demo. If you look at the directory tree, the top level files are basically the demo app. This is actually the example where it just displays all the tables and lets you run various queries and shows their effects on them. So those files are here. We don't really care that much about them because what we want to do is look at how it builds. It's built underneath, and then try to steal ideas from here in order to create this schema and vSchema that we need. So if you can see here, everything we need is under schema. This is, as you can see, this is already a multi-database schema. There is actually a user database or key space and a lookup key space. And under each one of these things, there is an SQL file that describes the schema, and there's a vSchema which talks about how this table, how the tables inside this key space are sharded. So we are going to basically recreate a similar directory structure under our my app, but then the tables and the vSchema information will be supplied by us, but we'll copy stuff from here as and when it's relevant. Coincidentally, the demo schema and our schema are very similar. We also have a user key space and lookup, and the demo also has the same thing. So it'll make it easier for us to transport ideas from here into our new schema. So I'm going to create the same directory under my app. Okay, dir /p schema /user and /lookup. But then for the user schema, I'm actually going to copy the base schema into the user directory. Call it user schema.sql. And but however, I have to make some minor changes to it. So let's open that. I'll open this file. The main change we are going to make is get rid of auto increment because those are not applicable anymore. So remove this auto increment and remove this one. So once this is done, our step one is done. And as I go along, I'm going to actually keep this as reference to make sure that we haven't missed any step. So at this point, what we have done is we have actually created these three tables inside the user schema, and it is going to be sharded. So our plan is as follows. First, we are going to create the schema for lookup, which is actually these three tables, a user sequence, music sequence, and a music lookup. And then after that, we'll create a quick vschema for lookup, which is actually trivial. And then we'll go step by step, create the vschema for user, which is basically taking care of all these arrows and these extra boxes. So for the lookup, what we are going to do is look for things that are already similar in the demo. So let me open that file. And as you can see, the lookup has a user sequence and music sequence, which we need from for ourselves. So we are going to copy that. Let me open a brand new file for lookup. My app schema lookup schema.sql. And I'm just going to copy these lines. However, I am going to change these cache values to something higher. These values are low in the demo because they are supposed to show how these sequences work. So now we have created this. So this takes care of user sequence and music sequence. But we still need to create the music lookup table. So in the demo, actually, the the lookup table in the demo is actually sharded, is a sharded table. So and it sits in user. So let's load that schema from the example. So as you can see, music user IDX is the table, is the corresponding table. But in our case, we are going to actually put that in our lookup database instead. So create table. I'm going to rename this to music IDX. Actually, let's call it music lookup, since that's how we named it in the slide. So this is going to be music lookup, and obviously no auto increment. And the target, as you can see here, is a key space ID, not user ID. So the Vindex that can use a user ID is actually a different one. So we'll use the one that maps it to a key space ID. And the primary key is a music ID. This basically makes it a unique Vindex, which means that there is only one target key space per music ID. Oh, and one thing I realized, the key space ID type should be actually actually a binary 8 would do the job. So the Vitess the key space ID, the key range is actually not really a number. It's actually just a bunch of bits, and except that if you're using a int64 number, then it's basically 8 bytes of bits. You can actually have a key range that has more bits than a 64-bit number. So in this case, since we are using a 64-bit number, the key space ID won't be bigger than 8 bytes. So binary 8 would do the job. So with this, we are actually done with the lookup schema, and we'll then go to the next step. So the next step is quick. We are going to create the vSchema for lookup, which is actually pretty trivial. The only significant thing in there is to actually categorize these two tables, sequence tables, so that Vitess will know to use them when you need to generate IDs. So for this, I'm going to take a look at the lookup schema, vSchema. Let's load that up, which is this one. So as you can see, it's pretty small. And I'm going to create a corresponding vSchema in my app, schema lookup. Okay. I'm just going to copy this whole thing. So the lookup vSchema is unsharded. As you can see, the user sequence is typed as sequence, same as music sequence. But we don't have a name user IDX table in there, but we instead are going to have a music lookup, right? Is it the name? Music lookup, yeah. We're going to have a music lookup table, and there is no special properties with that table. It's just a table that the vSchema will point to just for lookup. And that actually finishes the vSchema for lookup. So our next step, so at this point, we have categorized these tables as sequence, and the vSchema for lookup is done. So the next we are going to do is take care of some of the green arrows, which basically means that we need to define this user IDX index, and then show the and also change specify that the user points to user IDX and the user sequence. The way we do that is actually by loading, we copy most of the stuff from the user vSchema of the demo. I have some Vim macros for searching files here. So now we are loaded, and we also need to open a brand new vSchema file for our demo. And we are going to basically start with an empty one, and we are just going to copy components from the user vSchema into our current one. Obviously, we are also sharded, so we copy that part. And we are then going to define the indexes, which is the user IDX. How we do that is we copy this stuff here. So it's the index, and since we named it user IDX, we'll rename it here just to be consistent. And user IDX, and we say that it is hash type index as we defined here. So basically what we have done is we have defined this box inside our vSchema. The next thing we are going to do is actually define the user table. We go down here and copy the table here. Paste it here. Comma. Get rid of the comma here. So in this, what we are there are two things that we need to take care of for this user table. One is this arrow, which points to user IDX, and the other is this arrow, which points to user sequence. So the first arrow, which is the user IDX, is basically the user ID column, but it should point to user IDX here. There is nothing special about the name column, at least not for our example, so I'm going to delete this part. But the next one is this arrow, which says that user ID has an auto increment, and it uses the user sequence column, which is done here, which is the column user ID has a sequence uses the user sequence here. So you can see that the user sequence table is not qualified. It's actually in the lookup database. The reason is because Vitess can resolve tables that have unique names. If you wanted, you could qualify this table by its key space name. So you could actually say it's lookup.user sequence. So let's leave it as lookup.user sequence here for now. So at this point, we have defined everything that is needed for the user table. So the next thing we'll go for is the music table. So for the music table, we first have to create this lookup index, which I will do now, and then we'll create the rest of the arrows. So let's go here, and let's see if we can steal something here. As you can see, music user IDX is actually exactly that. Not exactly, but pretty close. So let's copy that. And that is a Index. So we copy it under the Index section. Fix up the JSON. So here, let's look at each parameter. The music user IDX, we called it music ID. Actually, it should be called music IDX. So let's call it music IDX to indicate that it's an index. It's a Windex. The type is actually not lookup hash unique. The lookup hash unique is the one that maps a music ID to a user ID. We are instead going to use a simple lookup unique Windex, which actually maps a music ID to key space ID. And the table, so basically the lookup Windex actually requires additional metadata, which is essentially this arrow from music ID to this table. So you need to specify how to perform the map. So which is basically what's the name of the table? Music lookup table. And the from column is music ID, and the to column is key space ID, just like we typed it up. And finally, a lookup index can have an owner. The owner basically means that if you insert a row into the music table, then Vitess will actually also insert the lookup row for it. We'll create the lookup row for it. The reason why you need an owner is because these indexes can be shared, and we have to actually tell the system which is the table that is responsible for creating these lookup rows. So the music IDX box is now created, and this arrow is now defined as of those parameters. So now we'll take care of these two arrows that are coming from music. And that should be simple. We go here, look for the music table, copy it. It here, and in the column indexes, let's look at the chart. In the column indexes, the user ID actually points to user IDX. So let's fix that. The music ID points to music IDX. So let's fix that. And what else do we have here? And there is a sequence on music ID which uses the music sequence, which is already correct. So now we have finished with music. And finally, the music extra is just an entry. Let's actually copy from here. So music extra is, and there is no index on key space ID. Actually, there is actually no key space ID column itself. So this actually is your entire vSchema for user. So what I'm going to do is actually sabotage this. I'm going to actually introduce an error here. So basically, the reason why I'm doing this is to show you how to troubleshoot in case you got your vSchema wrong and what will go wrong and how to fix it. So I've actually pointing this user to a Windex that doesn't exist. So when we actually start up the app, it should fail. Let's see. So at this point, let's review. We have created, we have deployed the original schema into a sharded database. We have created the additional tables under lookup. We have defined these Windexes. We have actually defined each arrow. I believe I haven't missed anything. Yes, I think we have defined all these arrows. So basically our setup is complete. So we now have to see how to launch Vitess on top of this schema. So to do this, what we are going to do is look at how the demo does this. So I'm just going to launch the demo. And once it has finished launching, I'm going to look at what processes it has started up. So here, if I do a pgrep, run.py, it should give me a PID, and then I can do the look at the tree, which is PID. So as you can see, run.py has launched another Python script, which is called run local database.py. And this script has in turn launched something called VT combo. So VT combo is the magic behind this demo. What it is actually a single binary that contains all components of Vitess. It's basically Vitess in a box. It has a VT gate, and it launches as many VT tablets as needed for each shard, and it has its own log server all in one thing. So that makes it very easy to spin up tests with this binary. And but VT combo itself has actually many lots of command line parameters, as you can see with the expanded view. So it's kind of a pain to launch it by itself. So what we did was we actually developed a easy to launch Python script where you specify the high level stuff, but then it expands it out into the actual parameters that VT combo needs. So what we are going to do is actually commandeer this command line and then customize it to our needs. So let me shut down the demo, because after this we will be launching our own program, and the ports may conflict. So if you go here, let's actually go with this, and I'm going to start the script. Ignore what the current content. I'm going to show you how I came to that. So what I did was I copied that command line that we saw, and basically customized it to basically this is what I did. I'm just showing you what I did so that you know how I got the previous command line, and then went there and then added quotes here, and then basically the main thing that I changed here is, instead of this pointing to examples demo schema, I pointed it to my app /schema, and then I shortcutted the long path names so that it's more portable. So so the two things, as I mentioned, one is this my app schema that the schema did that you point to, and the other one is actually your topology. How do you want your shards to be deployed? So in this case, it says there are two key spaces. One is user, and the other is lookup. And user has two shards, which is -80 and -80-. And lookup is an unsharded database. So it has a single shard, and the shard name is 0. So this means so this is you could actually change these to more shards or less shards, and then experiment later. So for now, this is the launch script. But of course, we know that this is not going to work because we sabotaged the vSchema. So let's see how this thing fails when we launch the program. So let's do a launch. So as you can see, there was a failure. And because Vitess has multiple components, most of the errors often go to the log file, so you may not see the error here. The way to look for it is actually, I just copy one of these roots, and everything is usually under there. So let me move to that directory and look at what is there. And there is a logs directory there, so I go change there, and then look at what's there. I'll cat vt combo. And as you can see, it says that when I try to save the vSchema, Windex foo user IDX not found on table user. So this is the problem that you saw. So this is basically how you troubleshoot. If something fails, you go look for the log files and see if you see any error. So we'll go back to our script and fix that vSchema, which is this is the demo. Discard this and this one. So let's fix this again. Let's hope I've not made any other errors, but we'll know soon. But before I go back and relaunch, I need to figure out, because usually if a failure like this happens, there are probably stray processes still running. So the way to look for it is to do a pgrep for VT data root. So anything that has VT data root is most likely launched by this program. So I need to kill this. So I'll just do a pkill-f VT data root. And everything should be gone. So now I can relaunch. Let's see if it works this time. Oh, no, it didn't work. So something else failed. Let's look at the logs. Music user IDX not found in table music extra. So I guess when I did the copy paste, I forgot to rename this Windex. So this should be music IDX. There you go. Yeah, music IDX. And we go back here and do the pkill. Now I don't even have to look at what is there because I know this would kill everything. And do the launch again. And there you go. So if the launch was successful, it'll print these this JSON output. And the important thing to notice is this port 12348, which is your MySQL port, and 12345, which is the HTTP port. So let's go start a MySQL client. The host is a localhost or IPv6 localhost address, and -p, capital P 12348. All right, so MySQL is running. Let's see if we are connected. Let's do a show databases. And we are connected. And this is actually the list of key spaces. So you could now do a select star from user, for example. So the one thing you may want to verify is what is Vitess doing under the covers when I send these queries. So that is something that you can do using curl. So VT combo actually has a query log that actually streams every query that it executes. So you can do that by doing curl dash no buffer silent localhost colon 12345, as you saw in the in here. 12345 was the port that the HTTP server is on. /debug/query log. So if you hit this, And then let's go back and run the query again, and then look at it. It has now printed what it has done. So basically, select star from user is a scatter query, so it has sent it to both shards. Of course, this output is kind of painful to read. This actually is what we use when there is very difficult problems with the system where you have to look at individual queries. We look at this query log. It has a lot of information about a lot of timing information and what plan it used. So it's very useful for troubleshooting. So now what I'm going to do is actually, and this is actually a tab separated line. So what you can do is actually run it to awk. Interactive, and then the field separator is a tab. So I'm going to do a tab, and I'm going to say print. I know that this is the 13th field where the query is, so I'm going to say print 13, and I'm going to run this. Oh, I missed a typo. It should be capital F. Okay. So now if I run the query again and go look at it, now you can see that it has done this. I messed up my demo a bit, so I had to reset. I now brought it back to the point where we left off. We just ran some queries on user and made sure that curl reports what's going on. So now what we have to do is actually test this and make sure that it is working as intended. So the first thing I'm trying to do is actually insert. Actually, this insert is going to fail into user name values test. So the reason why this will fail is because we are not inside a transaction. So by default, Vitess runs in non-auto commit mode. So unless you do a begin, it won't let you perform any DMS. So, but if you could execute this using a begin, or instead you could also do set auto commit to be equal to 1. So now if we insert again, the row gets inserted. We should be able to read it back. So it's the value 2. The reason is because the previous insert, even though it failed, it did fetch a value from the sequence. So the number 1 got reused. So I'm going to do 2 more inserts, basically mainly to make sure that the value 4 gets inserted, because 2 and 3 are in shard 1 and value 4 is in shard 2. And you can now verify that you can actually go to each shard and verify, like through the use statement. So you can say use user :-80 and select star from user. You say 2 and 3 are in shard 1. And if you go back to 80 dash, it will say 4 is in shard 2. So now, so we have verified that the user index works fine. We now have to see that this entire mechanism of music lookup, music, and everything else works fine. So I'm going to insert a row into music. So actually I should exit because now I'm connected to a single shard. I know how to unuse the database. So now set auto commit equal to 1 and insert into music. And in music, I am going to let's actually add a music to user 4, which means that it will do the second shard. Music ID should be auto-generated, so I should only specify user ID. So music user ID use 4, and say it's inserted. Let's actually look at the log to see if it did the right thing. Here, so the first thing it did is inserted an entry into lookup, which is 1, and this is the key space ID. It's binary. And then it inserted into music values 4, 1. So this looks right. We should still verify. But before verifying, let me see if I can actually do one more insert to this. Maybe values 2. yeah, 2 should work. And so this second music is inserted in user 2. And if you go back and look in here, it said it inserted 2 and 2 and 2 are created. So this means that I should be able to query the music table, select the music lookup table from music lookup. It should have 2 rows, which it does. Since it's binary, it's kind of messed up, but that's okay. I think you can probably hex up key space ID. It's okay. And the next thing we should do is use user :-80 and select star from music. It has the music for user ID 2. And if I say use user :80 dash and select music, it has so everything is in the right place. And now, just to make sure that the reading works fine, you say select. Let me actually select from music, where user ID equal to 1. This should know that user ID equal to 4. This should know that this is the second shard, so it should do only 1 read, which it did. And if I did instead music ID equal to 1, it should actually use the lookup to figure out which shard to send the query to. If it did that, and as you can see, it went to the lookup, found out the key space ID, and then used that to fetch this value. These 1 is not equal to 1 queries that you see, those are things that VT tablet does to cache the field information. So they are one-time execution, and if you do this again, it will not repeat it, for example. See, you can see that it doesn't repeat it. So everything is working, and now you are free to make changes, add more rows, and obviously the thing that you should do is run your test here. And if you run it, you will see that one of the queries has failed, which is the count star, and it says that this is an unsupported feature. We don't support scatter with gates yet. Of course, this is a simple query, and as time goes, we are actually adding more features to V3. So sooner or later, this construct will be supported. And the reason this is slightly lower in priority is because these queries are easy to work around in the app. But if there is something that you get stuck with, you can come on Slack and let us know that you have a query that's blocking you, and then we can try to get that particular construct prioritized. And we saw on that port 1, 2, 3, 4, 5, actually there's more information that you can mine out. Like, for example, if you go to debug/query plans, VTGate tells you all the queries that it has received and what plans it has built for them. So if you want to know how well a query, how VTGate plans to execute a query, this is a good way to take a look at that. So this pretty much concludes the tutorial. Just to recap, what you have to do is pretty much start with your schema like this, and then draw some pretty pictures, some arrows and boxes. And once you're clear about what you want to do, you head out to your app directory and then create a tree like this, where you define your sharded and unsharded key spaces, your V schemas, and once you have done, you then run to a custom launch.sh script, which you can copy from how run.py launches in the demo. And then once you have done that, you can just connect using MySQL and try out some queries, or you can write a test program like this, which uses some test files to run a large number of queries and see what works and what doesn't. So that's it for now. Thank you for listening.